Alright, welcome to Chapter 11, Section 4, called Equations of Lines. This is for Integrated Math 1, or IM1. A couple of things that you'll notice on the start of screen here. The first thing you should notice is a due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. You always have unlimited attempts on homework, tests, and quizzes. The number of questions just lets you know how many are on this particular assignment. Grading policy is always best score, which means best, whichever attempt is the best one is one to keep. Partial credit is enabled, so if you answer 1 of 6 questions correctly, you get credit for the one question. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. That means once I click start, in the bottom right corner, I will see a submit assignment button. It's not on my teacher preview here, but it is on your student screen. This is how you finish an assignment. So when you're ready to leave this assignment, whether or not you finished all of the questions, you don't want to just close it with the X or close down your computer. You want to click submit assignment. That's how you finish your assignment. If you don't click that button, 2 things will happen. Number 1, Alex is going to freeze or lock all of your assignments and resources. That's what it means by you can't work on anything else. So it's going to assume you want to leave this attempt open, and it's trying to do that for you. Remember, it saves your place, and you have unlimited attempts. You do not need to leave this attempt open. So click that button so everything doesn't get locked out. The other big thing it does is it doesn't update the grade book when you don't click that button. So your account's kind of frozen all the way around until you click submit assignment. So just make sure, good habit, always get into clicking that button. On the side here, you see explanation, example, and message center. Explanation tells you you're going to lose a current question attempt because it's going to give you the answer to this question. So it's not going to give you the answer and then let you come type it in. Example shows you a very specific example of what you're looking at. So write an equation in slope-intercept form. It gives you the slope and the y-intercept. It shows you slope-intercept form again, exactly how to write it. You can close this and open another example if you'd like. You can also message your teacher directly from the screen. It attaches a picture so we know where to come help you. One other thing I want to note about this video, and you're going to see this question update in just a minute, I did reuse some videos from other previous videos that I made just to kind of save some time. So the numbers may not match up here on the top, but they are in the correct order. So it is all 6 problems in the correct order. You might not see the correct number up top. Okay, so in this one, they actually just told me what the pieces are, didn't they? So write an equation in slope-intercept form of the line with slope 1/4 and y-intercept -3. All right, well, I flat out was just told slope and y-intercept. So we're going to have y equals, it's the slope times x. So they told me slope is 1/4 x, and then it's plus b, in this case it's -3 because we're subtracting, it's a -3, so plus b becomes -3. So I just plug those 2 pieces in, right? So I can come over here just to make that a little clearer because I didn't write this out, equals x. They told me that my slope was 1/4, and they told me that my y-intercept was -3. So I just simply plugged those in and wrote the equation out. I know it was going to be y equals with an x there. I just needed to fill in those other 2 pieces. All right, let's keep going here. A couple more. Oh, that's ugly. I don't like that. That's going to take too long. Let's rewrite it. Okay. Minus, and then remember this is our point, our coordinate, x, y. All right, so in this case it says a line passing through the point -10, 2, so it's giving us a point, and it has a slope of 3/2. Write an equation in point slope form of this line. Remember, this is point slope. That's this guy here. We have a point and we have a slope. All right, so we have our coordinate, it's -10, 2, and we also have our slope, right? Which they're just telling us is 3/4. That's going to go right here in the same position. So now I need to make sure I write these in the right spot. So y minus y and x minus x. So it's minus negative. So I can kind of show you. It's going to look like this. X minus -10. Well, instead of writing minus -10, it's going to turn into a plus 10 like this. I don't know why that came out so ugly there. Plus 10. So that is our equation. y minus 2 equals 3/2 times x plus 10. There we go. Oopsie. Dang it. I forgot to hit the over arrow. So x plus 10. There we go. Is that correct? That looks good to me. All right, one more of these guys. Okay. So with this one, this is a little bit different because now we're given a graph. Can we still do this from a graph? Of course we can. We just have to kind of think it through a little bit more as far as what are they telling me? What are they giving me? So they're giving me 2 points. I only need 1 point to plug it in, but they're not telling me flat out what slope is. And in order to do slope, I need to know rise over run, meaning to get from one point to the other, how far did I go up or down? How far did I move right or left? That's what slope means. It's the change in y over the change in x. And y is our up and down, x is our left and right. So again, just directions. So if I'm thinking of slope, if I want to go from this point down to the same line as this one here, well, I'd need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to go down 10 units. So I'm going to go like this, negative 10 over, let's see, is this the right line? I want to make sure. So I went down 10. Now I want to go, how far over do I have to go? 1, 2, 3, 4, 5, 6, 7, 8. So negative 10 over 8. The only problem with negative 10 over 8 is they're both divisible by 2. It's even. We don't want to leave it 10 over 8. I need to divide by 2, like this. So instead of negative 10, I'm going to have negative 5, and instead of 8, I'm going to have 4. So I'm going to rewrite this just so that it's not so funky looking. So it's going to be negative 5 over 4 instead of 10 over 8. Sorry, negative 10 over 8. So I reduced that, and we can even test this out and go 1, 2, 3, 4, 5. 1, 2, 3, 4. Ooh, look at that. I landed right on top of there. So it kind of skipped over this point when we went all the way down to this other one. There's actually 2 slopes. Kind of an idea. We skipped the first one if we did rise over run. So we could have done it twice. All right. Now what we have to do is pick one of the 2 points. It truly doesn't matter which of the 2 points you choose. You just have to choose one of these 2 points. You could even choose this one here if you want to. As long as you know that it crosses right over that point, that's fine. So I'm going to go ahead and choose this one up top because, again, it doesn't matter if I choose this one here in the middle, or this one here at the bottom. I can choose any one I would like. So for this one, I want to go 1, 2, 3, 4, 5. That looks like, yep, that's 5. That's negative 5 for x. And I think that's going to be positive 5 for y. So now I have y minus y and x minus negative x. So remember, 2 negatives, that's going to change it to a positive. So now I can go ahead and write my equation here. I have y minus 5 equals negative 5/4 times x plus 5. All right, lots of 5s in that guy. So get rid of this stuff from the last problem there. There we go. All right, consider the line y equals negative 8x plus 8. So we have our slope and we have our y-intercept. Find an equation of a line that is parallel to this line and passes through the point 6, 2. Okay, so now they're asking us to do something a little different. We just learned point slope in the last section. So what they want us to do is go back to point slope form, which I'll try to do the color coding that I was doing here. We have y minus equals x minus. All right, so with this one, we're going to have a point and we're going to have a slope. So either way, we have to deal with slope here. Slope gets multiplied by x. Y is being subtracted from the y coordinate. X is being subtracted from the x coordinate. So we have now a point and a slope. Well, the reason they gave us this equation was just to grab the slope from it. So this is slope-intercept form, so I know my slope is -8. If I have a parallel line, so parallel, that's going to be slope of -8. If I have a perpendicular line, perpendicular, I spelled that really, really funny, perpendicular, then I'm going to have the slope of the negative reciprocal. Remember, there's a 1 under here, so I know we don't always put it there, but we're going to flip it over, and then it was negative, now it's positive. So there are my two slopes that I need to write these equations. And I'm going to use this point slope form. I'm given a point here, so I already know what my y and my x are going to be. So and I'll start with parallel, since that's the first equation they're asking us to do here. So y minus equals x minus, and I'm just filling this part out. Then we're going to do the same thing for the perpendicular one, actually, so just so I don't have to keep flipping my colors here. So the point they're giving us is 6,2 for both of them. So remember, it goes x then y. I have my y minus my y coordinate and my x minus my x coordinate. And I can fill those in for both of them. It's the same point for both. Now what I'm going to fill in is my slope here in front of the x. So for parallel, it's going to be the same slope. For perpendicular, it's going to be the negative reciprocal. And be careful, when I say negative reciprocal, I'm just saying flip it over and flip the sign. Doesn't mean that it's going to end up being negative. If we started with a negative, it's going to be a positive. I'm applying a negative to it. I'm flipping the sign is what negative reciprocal means. All right, we can type these guys in just like this. It didn't say what kind of equation we had to write. It wasn't being specific on, point slope or slope intercept. So these are legitimate equations in point slope. We are good to go. X minus 6. And then I'm going to be a little lazy here, and I'm going to copy this. So I'm going to Control C, and I'm going to Control V, that paste it. And now all I have to do is go like this and go 1/8, and I can fix it really easy instead of having to retype the entire thing in there. Uh-oh, which part did I type incorrectly here? Oh, I put a negative on there. I forgot to take my negative off when I copied that. There we go. Recheck. All right, there we go. So, and you can use the graphing calculator in here. It opens up. You can type in some lines. You can actually get to see how they react to each other on here. You can change the colors if you want to, things like that. So the graphing calculator can definitely be a good visual tool. All right. So let's go ahead and keep moving here. Well, but maybe they found a better price now for renting the truck. So, because obviously this is quite a bit cheaper. So we're still going to have C, which is the total cost. And we still have S, which is the amount in sugar. So amount of sugar. All right, so, and we already kind of worked out this equation on the last one here. So it's going to be C, the total cost, is going to equal my no matter what, I have to pay $2,600, plus my additional fee. And remember, it's $100 for each ton of sugar. So I need to make sure that that gets multiplied. So here's my equation. Very similar to the last one we just wrote. In fact, it's almost identical as far as the pattern there. I'm just updating the numbers. Depending on what you see on your screen, you may or may not have the same story. The story just gives us context to what's going on, but it really shouldn't change the process here. You're going to have something very similar to, this is my starting point. No matter what, I have to pay this amount, and you're going to have an additional cost. So it'll be, per ton of sugar or per mile or per hour, something along those lines. You'll have some kind of additional cost. Okay, and now they want us to graph this. So if no matter what, we're going to pay $2,600, that's our starting point. So at 0 tons of sugar, I'm going to pay $2,600. And if you notice, I can't graph that like this, but if I click on this little plot a point, then I can go, if I have 0 tons of sugar, then it costs me $2,600. And there you go. It popped up there for me. So I can click plot point and it'll stay there. So the next one, I want to see how much is going to be for the next one because I need at least 2 points here. So I can go C equals 2,600, and they're not telling me what to plug in. I'm going to choose what to plug in to find my next point here. So I'm just going to go ahead and go with 1 ton of sugar. So this is going to be 100 times 1, which is 100. And I'm just going to add that to my no matter what cost here of the $2,600. So that's going to be 2,700. Which again, I still can't quite graph on my own. I do need to use this to go 1 ton of sugar costs 2,700. And I'm going to click plot that point. Now I'm going to close this and I'm going to connect my line here so I can see the pattern. Oh, I think it wants me to expand this over. The tool is just being a little argumentative. There we go. So now we can see, and I can follow this now too, and I can say, you know, okay, well for 9 tons of sugar, it's going to cost $3,500 because I can see that's where the line crosses here. So once I have those first couple of points plotted, I can use this to keep predicting and use it visually to see how much it's going to keep costing. So let's go ahead and check that, and we should be good to go.